So from where we stop at we are talking about alkyne. I've been able to differentiate between the three with respect to what's the name of what type of bond we have in them, what type of hybridization we have in them, then what type of is it saturated or unsaturated, then their general formula. So I was talking about the third one in the previous video. Now I said we cannot really say there is existence for methane because we have formula C like I've proven. There is no existence for ethyl as well because I have it as what? C2H2, and we are treating just triple bond. Even the triple bond cannot work for this. So the third member of alkyne is propyne, and that is what we have on the board. So in propyne we have C3H4. So let's see how we can draw the structure. So I have C. Then I have the triple bond here. I have told you here is open, here is open, and here is open. So here, open to nothing, open to nothing, open to nothing, open to nothing. So I have here connected to hydrogen, here open to hydrogen, here open to hydrogen, here open to hydrogen. That is the structure for propyne. Let's count now. 1, 2, 3, 4. So here is open, here is open, here is open, here is open, and that is why we call it what? Triple bond. I can rewrite this as C H3, C H into 3, then into C without H, then into C with what? H. That's another structure. So this is organic chemistry, and it is very simple. All you need to do is to understand the basis. So this is a structure for propyne, and that's why I can write the structure like this: CH3C, then the triple bond, and then we have what? CH. Now we can go from propyne. The fourth one is butane. That is when N is 4. So let's see the structure. So C4. Now H 2 times 4 minus 2. So I have I have C4. What is 2 times 4? That's 8. And what is 8 minus 2? 8 minus 2, is that not 6? So I'll be having H6. So let's see how we can draw the structure. So from these two structures, you can try the remaining one yourself. So let's see, I hope you have learned the structure of this. Please see this very well. This is propyne, and this is a molecular formula. This is a structural formula for this. And this is how I derive. I use this in deriving this. And this one I'm talking about is now butane, the fourth one, butane. I use the formulas, meaning this is a structure. This is a formula for butane. So let's see how the structure look like. Let's see how the structure of butane look like. Let's see how the structure. So I have C into 4 places. I can decide to put my triple bond here. So meaning here is open, here is open, here is open, here is open. Then here can be covered. I can have here connected to hydrogen, then connected to hydrogen, connected or bounded to hydrogen. I think it's complete. 1, 2, 3, 4. Then I have 8 here. Is it 6 or 8? 6. So 1, 2, 3, 1, 2, 3. So I can, this is a structure for butane. I can as well rewrite this as CH3, then I have C, then I have the triple bond, then I have another what? C, then I have CH3. So CH3 into C, into the triple bond, into C, then to C, and another CH3. So it's very simple. What you just need to read to understand the basis. So I think from the two examples, from each of them, you can generate other names of hydrocarbon or other names of alkane family, their structural formula, and molecular formula, and their structural formula as well, or molecular structure. So other member of alkane and their molecular formula and their molecular structure. Then other member of alkyne and their molecular formula and their what? Molecular molecular structure. Now that is on that. Now there is something we call isomerism. Okay, let's look at this one first, because this one is a little bit very complex. So I'm coming back to this. So I am done with hydrocarbon. But I want to relate that hydrocarbon now to homologous series and what? Isomerism and what? IUPAC name. Now, when we say the series is homologous, homologous series is a series that are bounded with the same molecular formula. And this bond is different by a methyl group, and that is CH2. Let me take the definition again. Homologous series is a series bounded with the same molecular formula, meaning the bond has the same molecular formula, and this molecular formula are different by a methyl group, which is what? An alkyl group, and this is an example of alkyl. This is methyl, alkyl, methyl. Okay, what am I trying to say? Now, if you look at alkane very well, alkane has CN H2N plus 2. Now, this one has CN H2N. You can see between this and this, I have different of CH2. For instance, let me make it very clearly to you so I understand what homologous series is. Let's pick propane, butane, for instance. Butane, that's C4H, if I'm not mistaken, this is butane. Now, let's come to alkene family now. So we want to take butane. So C4, butane, then I'm talking about the family. So 2, that this is what? 8. Then let's talk about butane. C4, then I'll be talking about 8, 9, that is what? 6. So you can see that the difference between them now, 2 hydrogen is lost from here to here. Another 2 hydrogen is lost from here to here. So you can see that all of them are different with C what? H2. All of them are different with CH2. Now, because different, meaning the difference between them is CH2, and that is why they are called homologous series. So homologous series is a series bound with the same molecular. You can see that the same molecular formula bound all of them, and you can see CN H2N. This one to CN H2N, that one to CN H2N. But the difference between them is that +2 here, then no +2 here, then this one is what? -2. So they are bound with the same molecular formula, but they are different with a methyl group that is called CH2. Now that is what we call homologous series. I am still coming back to that. Then we also talk about isomerism. What is meant by isomerism in chemistry? Isomerism can be said to occur when two or more organic compounds have the same structural formula, but have the same molecular formula, but different molecular structure. I take it again. Isomerism is the occurrence of 2 or more compounds. Is the occurrence when when 2 or more organic compound has the same formula, but they have different structure. That is what they call isomerism. For instance, look at this butane. For instance, butane. For instance, I want to explain isomerism very well. Butane has C4, if I'm not mistaken, then H. This is 8, this is 10. So let's draw this structure. I have C. I have this. I have this, I have this, then I have this. We continue from the next time.